Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. My name is Suswatul Hasana. Before starting my presentation, I'd like to thank the International Conference of Pharmaceutical Sciences 2022 for this great opportunity. In this occasion, I'm going to present our SCAR research with the title Formulation of Orally Disintegrating Film, ODF, loaded with piperine-succinic acid cocrystal. Piperine is an alkaloid, a secondary metabolite found in the Pipernigrum and Piperlongum species of the Piperaceae family, with many pharmacological activities and currently being developed as a nutraceutical. But sadly, piperine is practically insoluble in water, approximately only 40 milligrams per liter. Therefore, in biopharmaceutical classification system, piperine belongs to the class 2, where the absorption process will directly affected by the solubility as the rate limiting step. Solubility, the phenomenon of dissolution of solute in solvent to give a homogeneous system, is one of the most important parameters to achieve the optimal concentration of drug in systemic circulation for desired pharmacological activity. Various techniques are used for the enhancement of the solubility of poorly soluble drug, which include physical and chemical modification of drug and other methods like particle size reduction, crystal engineering, salt formation, salt dispersion, the use of the surfactant, complexation, and so forth. In our previous research, we've succeeded in enhancing the solubility of piperine by 4 times higher by engineering the cocrystal with succinate acid as the conformer. And in this research, we formulate the cocrystal into a formula with hydroxypropylmethylcellulose as the film-forming polymer and polyethylene glycol as the plasticizer to form an optimal orally disintegrating film base. The co-crystal of piperine-succinic acid in 2 to 1 molar ratio were prepared by the slurry method. Firstly, the piperine and succinic acid were weighed accurately and placed in the mortar. Then few drops of ethanol was added and the mixture was ground manually by using pestle until the solvent evaporated. This process was repeated and the resultant sample was reverted to LAG or liquid assisted grinding sample. And in other glass container, sealed glass container, another batch of piperine and succinate acid were mixed in ethyl acetate solvent. The liquid assisted grinding sample was added into the container and stirred for 24 hours by using magnetic stirrer. This method is known as the slurry method. The co-crystal obtained were filtered and stored in the desiccator until further evaluation. The co-crystal was subjected to different scanning calorimetry or DSC analysis for formation confirmation, for the co-crystal confirmation. Meanwhile, the other bases were formulated with different concentration of HPMC as the film forming polymer with the concentration at 4% for first, third, and fifth formula, and 6% for second, fourth, and sixth formula. And polyethylene glycol 400 as plasticizer with concentration of 0.6% for first and second formula, 1.2% for the third and fourth formula, and 1.8% for fifth and sixth formula. The ODF were produced by solving casting method. The formula was divided into two parts, and the aqueous and the ethanol phase. Sorbitol, citric acid, and polyethylene glycol were prepared in the aqueous, and the polymer were added to this solution. The other recipients were prepared in 50% ethanol. These two solutions then mixed together and let still to remove the bubbles before poured into molding chamber. The wet mass was then dried at 40 degrees Celsius for a few hours before removed from the mold. Each formula were evaluated for organoleptic characteristic, uniformity of weight and thickness, pH, moisture content, swelling capacity, and disintegration time. The base formula were used as the ODF base to be loaded with piperine cocrystal, and the loaded ODF were subjected to the same evaluation and for content uniformity. The research showed that cocrystal were formed, confirmed by the single endothermic peak at the same melting point from the previous research, around 109 Celsius degrees. The lower melting point given by the cocrystal often correlated to solubility enhancement due to lower energy needed to break the intermolecular bond, so it can dissolve uh, easily than the intact piperine. As for the base formula, only the second and fourth and sixth formula form a film and can get easily removed from the mold, while other produce a sticky mass that probably correlated to a lower polymer use in the formula. So in this research, we can confirm that the formula need to be at least 6% of polymer to have a good uh, physically ODF formed. The three basis formula were evaluated as seen on the screen. The thickness uniformity and the pH shown are relatively undifferent. Meanwhile, the moisture content of the second formula is lower than the other formula. This formula will give a more stable ODF dosage form since it will less like to stick to the packaging or other dosage form. The second formula, swelling capacity, is also showed a lower number compared to other two formulas. And since the saliva doesn't secrete it in enormous volume, this formula won't need a large volume of liquid to disintegrate. So it would be preferably to choose the second formula as the base formula. And this also goes along with the time of each formula needed to disintegrate. If the second formula is the fastest to disintegrate. The second formula was then selected as the base formula to be loaded with the piperine-succinic acid cocrystal. Each OGF contained 10 milligram of piperine in form of the cocrystal. As seen on the screen, the loaded ODF have a yellowish color and tasted spicy since it contained piperine. The other evaluation showed similar result from the base evaluation except for the moisture content, which slightly higher than this, and the disintegration time was far more faster than the base formula when in 20 seconds the ODF was already fully disintegrated. This may cause by the loaded piperine cocrystal interrupt the polymer backbone, so it can get disintegrated rapidly. As the conclusion, the second formula with the combination of 6% HPMC polymer and 0.6% of polyethylene glycol 400 as the plasticizer was selected as the ODF based formula. And after loaded with the cocrystal, it can be rapidly disintegrated in less than a minute. That's the end of our research. We'd like to thank Faculty of Pharmacy, Universitas Andalas for funding this research. Assalamualaikum warahmatullahi wabarakatuh.